List of things that we need to know. First is, let's define forces. A force can only be expressed by describing what happens when a force is applied to an object. That is, we don't have direct definition of force, we see the effect of it and then talk about it. For example, we can express force as a push or a pull. That is, it can cause an object at rest to move. If something is not moving, if the velocity is 0, we can make it to be a positive, not a negative value. If the body is already moving, it can change its speed. That is, it can increase the speed, if not decrease the speed, or direction of the motion. Or it can make it go a bit that side, this side, back, so on and so forth. A force can also change a body's shape, if not size. You have seen all of this in your lower grades. We can increase, decrease the shape of the body, an object, that is, then we can make it flat, thin, whatever it is, it happens because of force. And this is how we define force. Then how do you represent a force? The very first thing that we need to understand is force is a vector quantity. That is, it has direction and magnitude. So it is done with the help of a ray. What is a ray? A ray has a start and never ending representation. So to represent the magnitude part, we look at the length. When you look at the length, it gives you the magnitude. And obviously the arrowhead, it represents the direction. So this is how you represent a force. Then how do you represent a big force and a, big force and a small force? Again, not small, force. So let's consider a reference force. Let's say F1. If I want to represent a smaller force, or say we have a smaller force, we do this. F, this is lesser. If I want to represent a bigger force, I'll represent this way, or larger. Of course, we can use scale factor wherein you can tell that F lesser is half that of F1. Even the length represents half and all of that. So if this is 100 Newton, this would be 50 Newton. This is 100, this is 50, and this looks to be around 140 Newton. The length means something. There's a scale factor to this. We'll be understanding this in time. I'm just trying to introduce it. An object, we know that can experience a lot of forces. Right? You yourself are experiencing at least 2 forces as of now. One because of gravity and one a normal force, which is keeping you away from falling down. And it can be, you might be pushed by your friend. So there are multiple forces that an body can experience, and we represent this way. And this also we'll be seeing in detail. Next thing is a support, if not a normal force. So when we come across a book which is there on a table, how is that it's there on the table? What I mean is, we know that the gravity is pulling it down. So it should fall down, is it not? But it's not. Why is it so? Because there is something called as a normal force. So what is a normal force? It's nothing but a force which is it is always perpendicular to the surface which is holding it, and it will act against the direction of the force. So this is an example of a normal force. This is a force which the gravity is acting on. Now we can also have something like this. I'll explain what is this. So let's first read that actually. Let me complete the diagram. Okay, so let's read the definition. Any force that supports an object against gravitational pull is your normal force. It makes an angle of 90 degrees with respect to the surface. See, if I happen to extend this, you can see that they make an angle of 90 degrees, is it not? This particular line and the surface makes an angle of 90 degrees. What if the surface is slant? Well, the gravity will still pull it down, but the normal force will be like this. Why? It has to be perpendicular to the surface. Again, it's an extra bit of knowledge. that I'm trying to teach you guys. So that there are a few basic things. It's not too difficult. So I'm just introducing it to you. So this is normal, that is making a 90-degree with the surface. So this is about your normal force. So main thing over here is I would like you guys to understand the representation of a force and the difference between how to represent a larger force and a smaller force. And one more thing is the subscript. When you write anything and you write below, like how you write powers, right? 2 to the power of 10. You write this above, right? Is it not? Similarly, we write things below to represent what it means. Like here I've written gravity. Here I've written normal. It is below the line. I mean below the word. It's known as subscript. So writing this also helps. It makes things, your diagram, interesting. So learn that as well, right? So this is known as subscript. Okay. So pause, and not too many things to write. Main thing is this. Definition of force is not must. You guys can leave that. Write this right hand side. And write the multiple forces and normal forces and all of this.